Hello, my name is Felix. In Lab 5 of ENGPHYS 2A04, Electricity and Magnetism, I built an electric motor with my lab partner Tazeen Sarkar. This is a video of the motor in action. As you can see, it spins indefinitely.
It's still going.
Here's a video of the motor acting as a generator as well. As the coil in the magnetic field moves around, causing a current, an electric potential is created, causing the fluctuation in voltage measured by the multimeter.
Why don't you try holding it in place and then
What do you mean?
see holding it in place and then spinning it?
It's zero? Or almost zero?
Yeah, and then see what happens when you spin it.
One to 405, yeah.
This motor works by creating a current through a coil inside of a magnetic field. As current moves through a wire inside of a magnetic field, a force is produced in the direction perpendicular to the current and the magnetic field. When the current is created in the opposite direction in the same magnetic field, the force produced will be in the opposite direction of the example before. In the coil, this principle applies, making it so that on one side of the coil, the wire pushes upwards, while on the opposite side, the coil pushes downwards. To spin indefinitely, the force from the motor would have to overcome the kinetic friction created by the coil spinning. More specifically, the spinning motion follows Newton's second law, but for rotating objects. This law states that the torque is equal to the moment of inertia times the angular acceleration. The angular acceleration is just how fast the spinning of the object in question increases. To increase the angular acceleration, we can do two things. Firstly, we can increase the torque by increasing the current as well as the magnetic field strength. We can also decrease the moment of inertia of the coil we are trying to spin. Our design of the electric motor was very simple. We used a copper coil, two paper clips, a paper plate, some flat magnets, and a DC power supply. The paper clips acted as supports to hold the coil, with holes for the coil to rest and rotate in. The leads of the DC power supply were connected to each paperclip, so that it would provide a current through one paperclip, then through the coil, and to the other paperclip. A magnet was placed under the coil to create the magnetic field needed for the current to cause the torque on the coil. Our first magnet was not strong enough, so we attached multiple flat magnets to each other. All of this was put onto a paper plate so that the design would stay in place. We chose this design because it was seemingly very simple. The idea was that the simpler it was, the more easy it was to execute. However, when building the device, it was not actually as easy as we thought. There were many problems and challenges that we faced along the way. When we were building the device, we found that the wires were so thin that the coil kept sagging instead of staying upright. As a result, we had to try many different things to make sure that the coil stayed upright. Initially, we tried to attach a straightened out paperclip as a sort of spine to make sure that the coil stayed upright while on the stand. This did not work because it was way too heavy. As a result, it would not spin properly. Next, we tried to make the coil smaller with less turns so that it would be light enough that the wires would be able to hold themselves up without any help. Initially, this did not work as it was still far too heavy. However, it was still a more promising idea than the design we had before. Next, we decided it would be a good idea to lower the amount of turns of the coil in an attempt at making the coil even lighter. Fortunately, with some additional design changes, this actually seemed to work. Changing the coil to make it lighter actually had another effect as well. It lowered the moment of inertia, so that it was much easier for the electromagnetic forces to spin as well. This, combined with increasing the magnetic field strength, as well as increasing the current to a relatively large current, allowed the motor to spin virtually infinitely. Overall, I did have a lot of fun with this project. We encountered a lot of problems along the way, and seeing everybody leave before our group because they chose to make a speaker was very disheartening. But we worked very hard, and we created an awesome motor at the end that worked really well in my opinion.